Hello, mathematicians. How's it going? This is Mr. Garcia, and here with another lesson for today. We are on lesson 8.5, which is about the chord-product theorem. We're going to talk about that in a little bit, but first let's go over our objective. I can apply the chord-product theorem to find the lengths of chords. So we're going to be looking at chords today. Specifically, we're going to be looking at two chords inside of a circle. Now, the chord-product theorem tells us if two chords in a circle intersect, the product of the two segments of one chord is equal to the product of the two segments from the other chord. Now, first of all, that word product, you're not sure what that word means. Now, first of all, that word product, you don't remember what product means? The product means the answer we get after multiplying. So the product is the answer that we get after multiplying some numbers. So what this tells us is if we multiply the two parts of one chord, that's going to equal the other two parts of the other chord multiplied together as well. So take a look at our example circle here. And I'm going to highlight this chord right here, chord AC. Now you see that chord AC is split up into two pieces, AE and CE. And I can write that down here. And so if we were to multiply those two together, then that would give us the same answer as these two pieces multiplied together. And that is DE, and here is BE. And so by highlighting our formula over here, that would be this part here. So you see how AE and CE are part of the same chord, and DE and BE are part of the other chord. And these two chords intersect at point E. So if I take the pieces from each chord, multiply two pieces from one chord, the answer that I get there is the same as the other pieces of the other chord multiplied together. Let's take a look at some examples to see how we use this theory. So our first example is pretty straightforward, which is a good thing because we want to see how we use this theorem. So the first thing we're going to find is the value of x first. And we see that x is right here. So x is the length of segment JN here. So in order to find that piece, we're going to have to use our chord theorem. Remember, that tells me that if two pieces of one chord multiplied together equals two pieces of another chord multiplied together. So how about this? I'm going to outline chord JL in red, and I'm going to highlight chord MK in green. And I know that these two chords are intersecting at point N here. So I have one piece of chord JN up here and the other piece of chord JN down here. So I'm going to start by writing out those two multiplied together, 8 times x. So I have 8 times x. Now remember, our theorem tells us that the two parts of one chord multiplied together is equal to the two parts of the other chord multiplied together. So now I'm going to look at the other chord, MK, and let's outline the two pieces of MK. So I have MN, and I want to do that in blue just to make it different. So I have Mn here, and I know that's 5. And the other part of this chord, now outline it in brown, is Nk or Kn, and that is 4. So that means that on this side, I have one piece of that chord of Mk, that's going to be 5. And I'm going to multiply that by the other piece of that chord, which is 4. And so what I end up with is 8 times x equals 5 times 4. Now again, if you're not sure how I got these numbers, make sure you rewind the video, go back a little bit to see how I got them. But basically, the 8, I got it from here, the x from here, because those two are the parts of the same chord, I multiply them together. Also, the 5 and the 4 are the parts from the same chord. Not the same chord as JL, it's the other chord. This part measures 5 and this part measures 4. So I multiplied those two pieces together. So now we have an equation that we need to solve. So let's solve it. 8x is still 8x. I'm not doing anything to that yet. But over here I have 5 times 4. And we know that that equals 20. So I have 8x equals 20. Since I'm trying to find the x and get x by itself, to cancel out 8, I'm going to divide by 8. I'm going to do that on both sides. So 8 divided by 8 cancels out. That gives me 1. And so I'm left with x by itself. 20 divided by 8. Plug that in your calculator and you get 2.5. So x is equal to 2.5. The next thing they're asking us for is the length of JL. So again, JL is this entire chord, and right now I only know the pieces. I know that one part from N to L is 8, and the other part from J to N is X. But now that I know that X is 2.5, then to find the total length of this chord, I can just add the two pieces together. So to find JL, I have 8 plus 2.5. And so if I add those two together, I get 10.5. So the length of JL here is 10.5 units. Now for MK, it's even better because I already have those two pieces. So I just add those together. 5 plus 4 is 9. And that's it. So remember that this chord-product theorem, I'm taking the two pieces of each chord, multiply them together, and set it equal to the two pieces of the other chord multiplied together. Now this example was very straightforward, but on your assignment, you're going to have some more challenging examples. So let's take a look at another one. So as you can already tell, this example is going to be a little bit more complicated because now instead of just having x, we have expressions. And we have two of them. So let's break this down though, because if we do this step by step, it'll be very straightforward, okay? So let's start, because we know that we need to find the two parts of the same chord and multiply them together and set them equal to the product of the two parts of the other chord. So we know our two chords are going to be QS and it's going to be TR. So we need to identify the two parts from chord QS. Let's highlight chord QS here, the entire chord in red, and then I want to identify the two parts of chord QS. So I'm going to use purple for this part, which is Q to U. And then S to U is the other part. So there's the two parts from chord QS. So let's write them out in our equation first. So I want to start with the whole number. I want the 2 to go first. And I'll show you why in a little bit. Because then when I put the parentheses, 7x minus 8, we see an expression where we know we're going to have to use distributive property because of those parentheses. I will come back to that in a little bit, but let's find the information we need from chord TR now. So I'm going to highlight TR in green, and I'm going to identify the 2 parts of TR. So we know the point U is where they intersect. So I'm going to have one part be from T to U, and I'm going to have the other part from R to U. And that shows me that the 2 parts for chord TR here are 4 and x plus 1. So again, I'm going to write the whole number first. I'm going to write that 4 first, and then parentheses, then I have x plus 1. Now I have my equation, so now I just need to solve this. I'm going to draw my line through the middle. And let's start here by using the distributive property. I mentioned that earlier. In case you forgot what that means, the distributive property happens when I have a coefficient in front of a parentheses and an expression on the inside. I'm going to need to multiply this 2 by the entire expression. So what that means is I'm going to take this 2 and multiply it times every term that I have inside the parentheses. So I have 2 times 7x and 2 times negative 8. So let's start with 2 times 7x. Both are positive, so positive times positive is still positive. 2 times 7 is going to be 14. And then I don't have an x on the outside, so this x stays the same. So I have 14x. Then I have positive times negative, because this is negative 8. Positive times negative is still negative, so I have a minus sign. Then I have 2 times 8, which is 16. And then on the right-hand side, I need to apply distributive property again. So I have 4 times x, and then 4 times positive 1. So 4 times x, positive times positive is still positive. 4 times, there's no coefficient here. It's just an x. There's no number in front of x. So remember, if there's no number in front of x, there is a little invisible 1 there. So I have 4 times 1, which is 4, and no x on the outside, so I bring that x down. Then I have plus positive times positive is still positive. 4 times 1, we know that's 4. Let's continue. The next thing we need to do is start canceling things out. So I need to get all my variables on one side and all the constants on the other. So if I look at my x's, first, do I have x's on both sides? Yes, I do. So I need to cancel one of them out. I always want to cancel out the lowest one. And in this case, that's going to be 4x. So I'm going to cancel out 4x by subtracting. Since 4x is positive up here, I subtract the opposite. But I need to do that on both sides to keep the equation balanced. So 14 minus 4 gives me 10x. Then I have minus 16. I didn't do anything to that yet. So I bring it down. This is canceled out, so I bring down the 4. And so now I have 10x minus 16 equals 4. Now, since all of my x is on the left-hand side, I want to cancel out the minus 16, move that to the right-hand side. Since this is minus 16, to cancel out minus, I add. I'm going to add 16, and I do that to both sides. So this cancels out. I have 10x. I bring that down. I didn't do anything with it. And over here, 4 plus 16 gives me 20. Now I want to get x by itself. I want to get rid of the 10 since I'm multiplying 10 times x together. To cancel out multiplication, I need to divide. So I'm going to divide both sides by 10. That cancels this out. I'm left with x. 20 divided by 10 gives me 2. So the value of x here is 2. The next thing we need to find is the length of TR. So remember, TR is the green chord that we highlighted here. And I want to find the length of that. I know that this part from R to U measures 4. But what I'm missing is the part that measures from T to U. I know that it's x plus 1. But I don't know what number that is. But luckily, now that we know x, we can take that x and substitute it into our expression. So TU, and I'm going to write that over here on the side, TU is x plus 1, but we know that x is 2. So I replace the x with 2, and so I get 2 plus 1, which is 3. So I know that TU is 3. And if I add in RU, which is 4, and I add these together, then I get 7. So the length of TR is 7. Since I know that this part is 3, I know this part is 4, I add those two pieces together to get the total length of the chord. Now I'm going to do the same thing with QS. So in order to do that, I need to find, of course, QU first. So I'm going to write that down here. So QU is 7x minus 8. But again, we know what x is. We know x is 2. So I'm going to substitute it into our equation. So 7 times 2, we know that's 14. And I have 14 minus 8 now, which gives me 6. So I know that QU equals 6. And then for the second part of the chord, which is SU, I know that that is 2. So if I add those two together, 6 plus 2 gives me 8. So the length of QS is 8. So on the surface, this example looks more complicated, but if you remember our equation solving steps, then it's not so much complicated. But again, if you do have trouble with this, then just rewind the video back to the beginning or the part where you got lost and take a look at that part. And if you're still confused, then please reach out to us. Now, this next example is specifically for pre-AP and dual language. Since it is a little more complicated, regulars, you're not going to be doing an example like number 3 here. But if you want to stick around and see how it's done, you're more than welcome to. Just know that in your regular geometry assignment, there's no problem like this. You don't have to worry about it. For pre-AP and dual language geometry, you will have a problem like this. So I recommend you stick around and watch how I do this. So again, here in this example, we don't have any whole numbers anymore. We have expressions for each part of our chords. So we're going to need to identify these, multiply them, and then solve for x. So obviously that's going to be a little bit more complicated. So stick with me as I show you how to do this. First, we still need to identify our chords. So let's highlight the chords in colors. We have G, E in red, and we have D, F in green. Next, we're going to need the parts of each chord, and we know we're going to be multiplying them together. So I know I have D, F, and I know I'm going to have G, E. So let's start with D, F, and my point of intersection is H. So from D to H, I have 3x plus 9, and from H to F, now I'll use pink there, I have 2x minus 4. So if I write that out, we have 3x plus 9 times 2x minus 4. Now you see how I put the two expressions back to back. No plus, minus, or divide sign in between them because we know we're multiplying these. And then that's going to be equal to whatever I get from G and E. So let's find those parts. So again, my point of intersection is H. So one part of GE is from G to H, and that's 6x minus 9. And the other part of G and E is from H to E. So I'm going to highlight that in orange, and that's x plus 1. So if I multiply those two together, my equation ends up looking like 6x minus 9 times x plus 1. So at this point, you're probably thinking, well, how do I do this? Hopefully you remember from Algebra 1, but if you don't, there are several ways. You can use the FOIL method. First, outer, inner, last tells you which parts to this multiply, but I prefer using the box method. So I'm going to draw a 2x2 box here. On the outside of the box, I'm going to put each expression that I'm multiplying. So on the top, I'm going to put 3x for this first quadrant, and then I put 9 on this second quadrant. Now going down on the side, I'm going to put the second expression. We put the terms of the second expression. So 2x and then minus 4. So you see that each term has its place on the outside edges of the box. So what I'm going to put inside the box are the products from each part that is on the outside of the box. So for example, and I'm going to use some colors here. For this part of the box, I'm going to multiply 3x times 2x. So 3x times 2x, first I'm going to multiply the numbers, the coefficients. So 3 times 2 gives me 6. Then I'm going to look at the x's, since I have x's on both of them. When I multiply x times x, that gives me x squared. So the product of 3x times 2x is 6x squared. Now I'm going to leave that there, and I'm going to multiply the rest of this out. So now I'm going to go this way. And I have the 2x, and over here I have 9. So 2x times 9, I multiply the coefficients first. 2 times 9 is 18. This doesn't have an x, but this does. So I just bring the x over here with me. Then I'm going to multiply 3x times negative 4. And again, I start with the coefficients. 3 times negative 4 is negative 12. Here's an x, no x, so I have just x. And finally, and let me do this in brown, running out of colors here, I have 9 times negative 4. So 9 times negative 4, first of all, positive times negative is negative, and 9 times 4 is 36. So now that I have each term of the equation I'm going to get, I see that I can combine two of these. So I want to circle these two in the middle because since they both have x, they are both x terms, I can combine them right now. So if I write out my entire equation, I want to start with the highest order term, which means I'm going to look for the one with the highest exponent. That's 6x squared. I'm going to write that out first, 6x squared. And then I have 18x minus 12x. So 18 minus 12, we know that's 6. And it's still positive, so I get plus 6x. And then I just bring down the minus 36. So that's one way to multiply binomials using the box method. With the other one, I'll show you the FOIL method, so you can decide if that works better for you, or if the box method works better, then you can use that. So for FOIL, we know we have first, inner, outer. I'm doing it wrong. I'm doing it backwards. I'm doing FIO instead of FOIL. There we go. So first, the F refers to the two terms that are in front. So I have a 6x and I have x in front. So I'm going to start by multiplying those two. 6x times x. First of all, coefficients, 6 times the little invisible 1 is 6. And then x times x is x squared. The O represents outer. So the two outside terms, if we think of this part right here being the center, 6x and 1 are both farthest away from that center. So those two are my outer terms. Now if I multiply those 6x times 1, 6 times 1 is 6. And then here's an x, but 1 doesn't have an x here. So I just have a single x. So from the outer terms, I get 6x. Then I represents the inner terms. The inside terms would be negative 9 and x. So I'm going to multiply those two next. So negative 9 times x. Again, there's a little invisible 1 here. So I have negative 9 times 1. That gives me negative 9. And then no x here, but I have an x here. So I just bring that x with me. So I get negative 9x. And finally, is last. And I'll use pink for that. So the last terms of each binomial, negative 9 and positive 1. So I'm going to multiply those two last. So negative 9 times 1, we know that's going to be negative 9. And so again, I can see that since these two terms have just x in them, these are my x terms, I can combine them. So let's start by writing out first 6x squared, because that's my first term in this equation. So 6x squared, and then I have 6x minus 9x. I can combine those two to get negative 3x. So minus 3x, and then finally minus 9. Well, that was a doozy, right? But the good part is that we got that part out of the way. So the rest of this is just solving the equation. So let's take a look at our first step, which would be to get the x's on one side, constants on the other. Fortunately for us, we see that we have 6x squared over here and the 6x squared over here. So if I start by canceling out those, moving this to the other side, to the left-hand side, well, I'm subtracting 6x squared from here, which means I need to subtract 6x squared from here too. So this cancels out, but if you look at this also cancels out because I'm subtracting 6x squared minus 6x squared. So both of these cancels out. Isn't that wonderful? Yeah, so that's the first step already done. So let's bring everything else down. So I've got 6x minus 36 equals negative 3x minus 9. So the next thing I need to do here, and hopefully this looks a little more familiar and we're more comfortable here, we need to get the x's on one side, the constants on the other. So I'm going to look at the x's first, and I do have x's on both sides, so I need to cancel one. I'm going to cancel out the lowest one, which in this case is negative 3x. So since this is negative, I cancel out negative with positive, which means I'm going to add 3x to both sides. This cancels out. 6x plus 3x is 9x. And I have minus 36. I bring that down. And I have negative 9 on this side. I bring that down. And so now I'm going to cancel out the constants from the left-hand side, get that to the right-hand side. So I have plus 36 here, and then plus 36 to cancel this out. So I bring that down. I get 9x. Over here, negative 9 plus 36 gives me positive 27. Finally, I divide both sides by 9, and I get x equals 3. But the hard part's done. Now that I know the value of x, now I can find the length of GE and the length of DF. But to do that, I need to find the length of each individual part first by substituting x into each expression. So we know that the length of GE is going to be the 6x minus 9 plus the x plus 1. Now, if you want to do this part by part first, you can do that. For example, I'll show you. Since I know x is 3, I'm going to substitute that in here. So I get 6 times 3 minus 9. 6 times 3 is 18. 18 minus 9 is 9. So I know that this GH is 9. Over here, since x is 3, I substitute that in for x. So I have 3 plus 1, which is 4. So I know that HE is 4. And if I add these two together, 9 plus 4, that'll give me the length of GE, which is 13. Now that's one way to do it. Just do it by substituting it into an expression, or you can also just plug it in into an equation. What I mean is take this expression and write it out and add in this expression and then just substitute it in there. So let me show you. So to find the f, and I'm going to write that over here, I know that I need to add 3x plus 9 together with 2x minus 4. So I have 3x plus 9 plus 2x minus 4. And so I have 3x plus 2x, that's 5x. 9 minus 4, that's plus 5. And so now I substitute in the 3, and I get 15 plus 5, which gives me 20. So the f would measure 20. So either way that you want, you're free to find the lengths using whichever method you prefer. I showed you both examples. You can use the both that I used. You can stick with one, whichever one is easier for you, whichever works best for you. You're free to work it out however you want, as long as you do it correctly. All right, well, that's the end of the lesson. I hope you guys didn't find it too difficult, but remember, if you did and you're having trouble with it, reach out to us. We're always available. Please let us know if you have trouble, okay? Well, I guess I'll let you guys go. Have a nice day, and I'll see you guys later.